We have a lineup of 6 speakers, so I want to get started as quickly as possible. And your slides are up, so...
Hi everyone, my name is Ida Janota, and my presentation is titled Linking Governance and Vegetation Cover Change, Taking Insights from Spatiotemporal Remote Sensing Analysis in Malawi. And it is a work that I've been doing in collaboration with a colleague of mine from the University of Connecticut, in the geography department. And what motivates this research, it's kind of specifically grounded in Ruth Diffrey's point this morning, her 3 slides of A minus, B, and D. And we were motivated by the poor understanding of how the different ways in which we govern land use explain the vegetation cover transition we see. And especially in the context where I'm working, there are limitedly established links between specific forest governance models and the changes in vegetation cover and in vegetation and tree cover. And like I said, such knowledge gap exists in a context where many interventions that intend to increase tree and vegetation cover, such as forest landscape restoration projects, we leverage and rely on those governance approaches, but we have no understanding of how effective they are. So it's a case of Malawi, which is a leading country in terms of implementing FLR projects. And for those of you who don't know, FLR is one of those so-called nature-based solution interventions that are supposedly offering both ecological and social outcomes while addressing climate change, biodiversity loss, and deforestation issues. So we think that if we can get more insight into the potential effect of different forest governance models that have been implemented over time, we could potentially reduce that knowledge gap on what effective forest and land use governance approaches can better support such projects. So for a bit of background, Malawi is a country in Southern Africa, and its environmental landscape are typical mosaic of interlocking agriculture and forest land. They are broadly partitioned into protected areas where we have forest reserve, but also non-protected areas that are mixture of agroforest landscape of Miombo woodland, because Miombo woodland is the typical ecosystem there. In terms of land use changes, the country has experienced more than 41% land degradation between 82 and 2006, and the deforestation rates and forest degradation rates, as you can see there, are respectively more than 38,000 per hectare per year, and more than 71,000 hectare per year during 2009 and 2015. And if we take the GWF and the Global Forest Watch data, there is a decrease in forests by 21% and in tree cover by 16% between 2001 and 2023. And in terms of governance model that the country has experienced, we have, in addition to the government-managed forest reserve that is the centralized approach, the country has adopted what we call the forest co-management since 2006 and community-based forest management since the 90s, which is like the turn, as part of its turn to the decentralization. And those two important governance models are what I'm going to talk about. There is a degree of devolution, different degree of devolution and ownership level that is important there. So it is in that context that the goal of this study is to understand where and how vegetation cover has changed across Malawi's landscape that have been subjected to those different forest governance. And we answered 2 questions. What is the nature and magnitude of the changes that we see from 2003 to 2021? And how do distant spatial patterns of vegetation changes correlate with different forest governance models? Maybe that's the A plus that would please talk about, the first question, and the second question might be the D. Good, thank you. So, in terms of methodology, okay. So we focus on those 2 different governance models that I talked about and use their respective spatial distribution and temporal occurrences for 3 major programs: Compass, IFMLSP, and Perform. Those are 3 different natural resource governance programs that were implemented. We use MODIS data, but also at 250 meter spatial resolution, and CHIRPS precipitation data at 5 kilometers that we aligned later on. And we use seasonal composites of EVI and also precipitation differentiated by wet season and dry season, and also monthly composite. In terms of analysis, like a good land change science, we kind of blend remote sensing and institutional analysis. And for the remote sensing, we use trend analysis with Mankendall and SendSlope method. So trying to understand monotonic trends in EVI and precipitation time series. And we use breakpoint analysis across those different periods of time that I'm going to talk about as I talk about the results soon. And that helps us to examine both vegetation greening and browning trends, but also to disentangle patterns linked to natural processes. Here we are focusing on precipitation and management approaches, which are the governance. So quickly, in terms of results, the overarching our analysis showed that while both greening and browning patterns were detected, indicating gains and loss in trees and vegetation cover, there were intriguing patterns like significant greening in the dry season rather than the wet season, and in the specific time of the IFMSP era. And also by the end of that period, we saw that. I will talk about that in detail. We also see reduced greening in the wet season for the study period, and especially during the IFMLSP period. So if we look at these things spatially, this is what we have. In general, the takeaway point here is that there was more aggregate vegetation browning than greening during the dry season. And we can see the numbers behind that representing just 5% of the land. But with exception that in 2005, if I can point, I don't know, in 2005 and 2014, and between the last period of the study areas, I'm talking about this one and this one, we see actually less greening. Sorry for my thing here. It should be my, not superior, but less browning than greening. The other thing, and that's the dry season. We did the same thing for the wet season, and I will quickly say we see net browning during 2005 and 2014. So because of time, I'm gonna go quickly. We also look at the precipitation analysis. Okay. So to disentangle the influence of precipitation, we did the trend analysis for the dry season and the wet season, and I'm not going to go into detail here. Now, what do we understand with the breakpoint analysis? At country scale, we were able to quantify the timing and location of the changes we are seeing, both greening and browning. And with the precipitation analysis, we observed that the greening and browning pattern were at country scale are not likely driven by precipitation changes. And we look at that also at district level, and we can see specific districts across time where we see the gain and the gain in vegetation and tree covers. What all of that led us to say is that when we bring the timing together with the quantity, we see that during the compass period, we see substantial net increase in vegetation greening, and greening during that time was higher compared to post-compass. Burning was really low. And when we look at the second one, we have missed greening trends during the IFMSP, and we have numbers behind that. And finally, we see overall greening decreasing during the perform period compared to pre-perform period, and also burning rates nearly doubled. What all that means, this is my last slide, is that there is still question persisting about the durability of the gain that we see in the changes. However, looking at the governance, we see that CBFM under compass was more effective in reducing degradation, while FCOM and underperform showed limited gain. And the interplay between FCOM and CBFM during IFMSC was really inconclusive. What it means is that when we look at the degree of participation and the ownership level and the evolution, it seems like that CBFM that gives local population more power, devolution, and ownership to their land, it's better than the co-management aspect, which gives them less ownership over the forest governance. So that's a preliminary analysis we did, and the idea is to put that in the modeling and adding other factors to really confirm this trend analysis that we had. Thank you.
I think we have time for one
question. We have time for one question.
Less of a question, more of a suggestion. Because when in a context of doing whole lots of trend analyses, you get into a problem of increasing the risk of type 1 error. Mm-hmm. And if you have your various administrative units, if you go for each administrative unit, look for twice the number of positive trends of negative trends, and then restrict that in each thing, I think you'll come up with a clearer signal, and as well as identifying places and periods where there's no significant difference.
Yeah.
Okay?
That's a very good suggestion. Because of here, I didn't talk about any numbers and specific quantity we get from the break point analysis. But yes, the conclusions here are based on having twice or more than twice the amount of greening to make to draw the insight. Yes, that's good.
So, unfortunately, we don't have time for more questions. But we can have discussion after if we have time or at lunch. So I'm going to move on to the next speaker, who is Lucas Alenkar, who is a postdoc at the University of Manchester, the first of our series of the University of Manchester talks. So,
yeah, this one here is fine. Okay. Thank you.
Can we get...
So, hello everyone. Let's start to not spend more time on that. So I'm Lucas, and today I'm going to talk a little bit about land tenure effects on forest cover and poverty alleviation using the Mexican ejidos as a case study. So there's a bunch of pathways identified so far that could lead to forest cover change, not only to deforestation but also to reforestation, which is the thing that we are more interested in. However, even considering all those pathways, all those arrows, this only focus on forests, right? So we know very little about the social outcomes of those forest transitions. what's happening to poverty and inequality, or even food security in places that are gaining forest cover, or in places that are losing forest cover? Are there any synergies or trade-offs between the different, policies, maybe land tenure schemes? And also, can we imagine other pathways? So, my project question is a lot on understanding the role of land tenure, different types of land tenure on forest cover and poverty outcomes. And also, how does the privatization of ejidos affected those forest cover and poverty? So, within this scheme, how land tenure also promotes, improves, prevents those pathways to realize themselves. So I decided to start studying the ejidos and comunidades in Mexico because, as you can see in this map, they pretty much cover 50% of the country. And this is a type of land tenure here in Mexico that it's very related to the agrarian reform that happens after the Mexican Revolution. So the revolutionary government gave titles to communities, to people, and they were pretty much divided into ejidos when they are more like local farmers or local communities, or comunidades that's more related to indigenous communities. So in those places, several activities happen, but most is agriculture. Different types of agriculture, so different ejidos produce different types of products. Some are more focused on crops, other more on cattle, or the different types of crops. Nonetheless, both types are collective territories, so a great part of the land are managed collectively. However, recently there were some agrarian laws that allowed the sale of parts of the ejidos to some people who already live in the ejidos, but also to foreign people. So, as you can see here in this map, those red lines are the ejidos itself, and some of the ejidos were already completely privatized. Others are still under communal land management, and there's a whole gradient between that, right? So. Also, another interesting thing about Mexico is the localities. Localities are below municipality spatial arrangement, maybe, of population. And this can span from a very small rural communities, such as this, or even to a very big urban areas. Nonetheless, many policies are applied at this level of those localities. And also, many indexes are developed. The country also try to understand itself using this scale. So there's around 200,000 localities. Of course, this number change over time. And that's how locality look like in a GIS program. So these are point data below the municipality level. And this was my unit of analysis, right? However, I only analyzed the rural ones, because I'm more interested in the rural context of Mexico, and also only forest biomes, because my interest is on reforestation. However, those point data is hard to allocate area for them, right? How we're gonna measure forest change in a point? So we build those decent polygons. We use this method to create this mesh of polygons covering the whole country, using each point data as the initial seed to build those polygons. And within each polygon, we calculate the percentage of ejidos that cover these polygons. We calculate the percentage of communal lands, the percentage of private lands, the percentage of communities, indigenous communities. Also, we calculate a series of covariates to build this CBGPS method, which is a horrible acronym that stands for Covariate Balancing Generalized Propensity Scores, which is essentially a weighting method to make all those observations more comparable. And also interesting, this method allows us to evaluate not only units that were treated versus units that were not treated. You can evaluate a gradient of treatments. So from 0% to 100%. We don't have actual control. We have units that were treated with 0%. And everything between 0 and 100%. And our outcomes of interest was change in forest cover and in poverty. From 2000 to 2010, and then 2010 to 2020. So, as I mentioned, our outcome was forest cover and a multi-dimensional poverty index, and we measured that in 40,000 decent polygons across the country. And that was regressed on our treatment, and we had these 4 treatments: the ejidos, the indigenous communities, the area of communal lands within those ejidos, and the area of private plots within those ejidos. To that, we added the baseline either for forest cover or for the poverty index. So to measure the forest cover in 2010, we put in the model the baseline of 2000. The same for our poverty index. And as I mentioned, we built those weights using that method, and those were the variables that were included to build the weight. So many biophysical variables on population, working population, indigenous people, also distance to different size of cities, area of agriculture, area of urban areas. And here a little bit of our results. I'm calling this just a preliminary results because we pretty much just started doing this. And on this graph is the poverty index that we use. This graph here is the forest cover. So the first one is about ejidos. So as you can see, sorry, this line is not, I'm not sure if that's very clear, the 0 line over there, but localities with higher coverage of ejidos had a reduction in poverty and an increase in forest cover. So we found a kind of synergy in here. However, those same localities with more indigenous land, we found that those areas had an increase in poverty, but not a very strong effect. When we evaluate the decent polygons with communal lands, with communal lands, as you can see here, the areas with more communal lands also had an increase in poverty levels. However, looking to forest cover, there is also a big increase in forest cover. So my slide's not well. So there is also here a trade-off. And looking to private lands, it was very interesting because those polygons with more private lands had a big decrease in poverty, even more than the areas with ejidos. However, also a big decrease in forest cover. So there is apparently a clear trade-off between having more communal land or having more privatized land, and in poverty and forest. Can you pass, please, the slides? Hello. Sí. Hola. Puede. Here it goes. So, highlighting here the trade-off. Yes, and I also did for both periods, right? So 2000 here and then 2010. And we also noticed that the effect size reduced a little bit. And here's some next steps. I definitely need to improve those models to consider more at least to add a spatial component to it, because obviously those things are not randomly distributed in space. There's a lot of history, and part of those history can also cause this, and this obviously is structured in space. So I need to add a spatial component to it. I'm also trying to understand how I can add a regionalization component to it, either maybe by adding a biome level analysis, or maybe a state level analysis, or some sort of other region analysis. And also testing maybe other matched approach, because it's good to have other methods. And I guess I'm done here now. Thanks so much for attention, and hope we're gonna have nice questions.
Thank you, Lucas. Pooja has a microphone back there we can have time for one question.
Quick question. Very interesting results. Do you have already some potential explanations to why we see this? Do you think it's the land tenure is reflective of something else, social cohesion, or some other practices that are driving some of this, or might be completely independent of those?
I guess this is a very new results, I would say, in terms of my work. So I'm still figuring out what could be an explanation of this. But definitely, most of the hedgerows are still a collective territory. So there's definitely a component on how decisions are made. It's not uncommon to have an hedgerow that set aside a forest, even maybe for forest management. So that's also a collective decision. And usually, those collective decisions may not change that fast. So, for example, within a private plot, it's just a single person or a single family deciding what to do if they forest or the agriculture, etc. So, yes, I would say that's probably a kind of how those lands are, the decisions over what to do within those lands are made.
I don't think we have time for more questions. I'm trying to stay on schedule, so I'm going to move to the next presenter. Also a postdoc from the University of Manchester, Katie Devenish.
Thank you. Cool, okay, thanks. I will get started. So yeah, my name's Katie. I'm a postdoc at Manchester. Me and Lucas chose the same presentation scheme. And I'm going to be talking today about a study I'm leading looking at the drivers of tree cover gains across very large scales. And I'd hoped, as the title suggests, to come here today and present to you some really cool findings about the things that are causing trees to grow back around the world. But unfortunately, it took a lot longer than I thought it would to get my outcome variable, because of various challenges that I encountered on the way. So instead, I'm going to talk about the processes of mapping global tree cover gains using secondary data, some of the decisions you have to think about and make, and then present some cool maps and statistics at the end. So yeah, despite kind of continued net loss of forest at the global scale, in many places tree cover is actually expanding. And some regions, some countries have even undergone a forest transition, which is a shift from net loss of forest to net gain. But why? What's driving these kind of countervailing trends? So we know that land use change is a product of multiple factors operating at various scales, and that can cause high heterogeneity. But what I'm interested in looking at is whether there are any common factors, any kind of common enabling conditions linked to local tree cover gains, but across very large scales. And the idea is that this analysis could help to fill knowledge gaps in places where there are no case studies, and also help to potentially better target restoration efforts to places where the conditions are kind of more conducive, or where it might be happening anyway and could do with a little help in hand. But I want to emphasize that this is an exploratory kind of causal analysis, not a predictive analysis. We want to look at whether the things that we think are causing trees to grow back actually are, and whether the processes outlined in the forest transition theory apply across very large scales. And the results will hopefully help to reveal the relative importance of more local scale factors versus national factors in driving tree cover gains locally, and also kind of the relative importance of forest-specific and land use policies versus kind of broader socioeconomic changes in driving these processes. And I also hope to repeat the analysis at slightly smaller scales, but still very large, kind of to test for differences. But to do all that, first of all, you need a global map of tree cover gains, which at the start I thought would be easy, but it turns out is not. And that's because of various reasons. So there's actually very limited data on tree cover gains compared to deforestation. So for example, the Hansen et al. Data only goes up to 2014, and there's only 1 or 2 global land cover data sets that have a long enough time series to look at gains and whether they last. If you're doing kind of a country scale or a regional analysis, you have more options, which is good. There are also challenges with definitions, which was what has given me a lot more grey hairs over the past several months. What counts as a tree? What definition globally do you set to define a tree? What counts as a tree gain? Does it count if the trees grow and then they're chopped down? Do you want to set some kind of minimum criteria for persistence? Those are all things you need to think about. And then finally, I mean, as you all know, the type of tree cover really matters. Natural and planted trees deliver very different benefits for climate, for people, for biodiversity. And so it's really important to differentiate. But again, the data on kind of planted trees is not ideal, I guess. So few countries kind of have spatial data on planted tree polygons, and especially smaller ones. And it can actually be very difficult to differentiate planted from natural trees in satellite imagery. Oh. Whoa. Yeah, okay. So these are the things that I decided to do. I decided to use the Potapov et al. Tree height data for 2000 to 2020, which is based on the modelled relationship between Landsat imagery and tree heights estimated using JEDI data. So it's not directly measured in those previous years it's modelled. I define trees as vegetation over 5 meters tall. In order to count as a tree gain, the trees need to have lasted over 10 years. And there are 3 kind of temporal trajectories that this could be achieved by. But basically, in order to count, a pixel needs to go from non-tree to tree between 2000 and 2010, and then remain as a tree in 2015 and 2020. And the idea is that if these trees have already lasted 10 years, then they're more likely to last kind of more longer term. And it also helps to exclude transient gains within shifting agricultural systems or short rotation timber harvest, where the chances are the pixel might be cleared again. And then I decided to use the spatial database on planted trees to differentiate between natural and planted tree gains. And for those of you who are not aware of this dataset, it's a global dataset on planted trees, including planted forests and tree crops. And it's a compilation of many different national and species-specific data sets, which means that the methods, the resolution of the data, and the definitions of planted trees vary around the world. And that means that a tree classed as a planted tree in one place might not be classed as a planted tree in another, which means there's spatial inconsistencies. However, I think that this could reflect the fact that in some places it is just really hard to distinguish between natural and planted trees, and the fact that understandings of these kind of categories also vary around the world. So one person's planted tree might be another person's natural tree. And here I'm thinking about kind of the semi-natural forests in Europe that have been planted ages ago. So yeah, I decided to trade off global consistency for what I hope is more local accuracy. But I also think that the extremes of the tree cover spectrum are probably quite well distinguished kind of consistently around the world. So your tree crops, your timber forests, compared to your natural forests. Okay, and then my unit of analysis is these 500 kilometer square hexagons. And I summarized my 2 tree cover gain layers within these hexagons to get a continuous measure. I think I'm going to have to speed up a bit. So, here is the first map of mostly natural tree cover gains, which I estimate covers over 700,000 kilometers squared. And these are presented as a percentage of land area within the hexagon. In contrast, this is the map of mostly planted trees, and you can see that it is a lot more spatially concentrated. I'm going to show these maps again at the end, so you can have a bigger look there. And then, so I thought I'd kind of explore a bit more in depth these natural tree cover gains, and I found that 87% of them occurred on lands which was not trees in 2000, so in these first 2 pathways. And of these pixels, kind of extracting the raw tree height data at these points, I found that 32% were already small trees in 2000. 62% was dense scrubby vegetation, and 3% of these gains through those pathways occurred on what was cropland. And this aligns with the theory of succession, right? So that's good. Then I looked at, this is for all natural tree gain pixels. I looked at how much they grew over the study periods. And I found that the average height change was nearly 11 meters. And that actually gave me a lot of confidence in kind of the gain measure, right? Because I was a little bit worried that it could just capture naturally small trees that just happened to grow a little bit over the study period to pass the threshold. But as you can see, most of these kind of pixels did experience substantial growth, which is good. So, next steps, very quickly. I'm going to use this horribly complicated theory of change to kind of get predictors, plug them into a multi-level model to kind of, to look at the effects of various hypothesized drivers. Just very quick conclusions. Studying tree cover gains is really difficult, and I know that much of this data is probably wrong. And many of you in the audience who are experts in these areas may look at that map and say that's nonsense. That's not natural tree gains. But hopefully it's still correct enough to be useful. And I think that as long as the relative differences across space are kind of pretty good, then it will be useful for my purposes looking at the effects of different drivers. And I also hope that it could identify kind of hotspots for future research. That's it. Thank you to my collaborators.
Again, I think we have time for one question. And Pooja has a microphone. Pooja, there's a question up here. Actually, I think I'm closer. Why don't I just...
Hi, thank you so much for your presentation. as a researcher now is studying open ecosystems and non-forest ecosystems, I was just wondering about those areas that I see, for example, in Brazil, in the center of Brazil, where you have like savanna ecosystems, or even in some parts of Africa. So how are you accounting that, as you wouldn't expect many trees in most of those cases, and they probably do not achieve the same height as you would expect in a rainforest, for example. So how are you accounting for that?
Thanks. Yeah, I think my height criteria will miss smaller trees in dry ecosystems. So, when I rerun the analysis for biomes, I can set a smaller criteria. So I can change it to 3 meters, which will hopefully be better suited. I do intend to do that. Thanks.
So we don't have time for more questions. The next presenter is my co-organizer and postdoc from the University of Minnesota, Pooja Choksi.
Hi, everyone. I want to talk to you about restoring tree cover within and outside forests, especially in South Asia. So everyone in this room is well aware that we're in the UN Decade on Ecosystem Restoration, and there are so many lofty goals with different objectives of meeting land degradation neutrality or climate mitigation. For example, one of these goals is the Bond Challenge, which involves restoring 350 million hectares of land globally by 2030. And there are several different ways to do this. And most of the science, I feel at least, has largely focused on understanding vegetation regeneration and the differences between restoration methods, understanding carbon sequestration of this tree growth. And what I think is really missing is, what about the people and biodiversity? And that makes a lot of sense because a lot of the restoration is ongoing right now. And so it's the best time to jump in and try and understand the outcomes for people and biodiversity. And today, I'm going to talk to you about 2 examples, as my title suggested. One of the examples is from within a forest. It's a dry forest. And the second example is from trees outside forests in South Asia. So, to quickly take you through the first example, I studied restored and unrestored tropical dry forests in central India. And tropical dry forests are those that go through a typical sort of dry season and wet period. And the sort of example that I looked at was a certain kind of restoration that was done through the removal of this invasive species called Lantana camara. And people from Central America might know it pretty well. The British brought it over in the 1800s, and it became highly invasive in the last few decades. So what people did over here in collaboration with a governmental and non-governmental agency, and when I say people, I mean some of the local communities, they went in, removed all of this lantana, and then I went in 3 years later and looked at how forests are growing back and how that impacts people and biodiversity. And I did that by looking at soundscapes. So I studied how biodiversity is impacted, specifically species that can make sounds, or what we call vocalizing diversity. We did that by leaving these acoustic recorders out for weeks together over several seasons to sort of understand the overall effect. There was a lot of ground truthing that I did, I must say that, but I'm not going to show you that today, but I'd love to speak to you about it because I know there are a lot of folks interested in this technology. But moving on to what I found. What I found is that restoration is positively, but not significantly associated with acoustic space use in the lower frequencies. And when I say acoustic space use, what I mean is this sort of sum total activity in that frequency range made by, in that range, actually audible insects. Most of the birds are in that frequency range, amphibians, even humans. And I want to show you this figure, and I need you to focus on the yellows and the blues. Please ignore the grays because those were control sites and we don't have time to go into that. But what you've got on the x-axis is time in 24 hours over multiple seasons. And what you've got on the y-axis is the acoustic space use. So sort of the acoustic activity by all of those taxonomic groups. And what we see here immediately is that the restored, which are the yellow, and the blue, which is the unrestored, aren't that different from each other, really. And that shows up in our models where we controlled for so many vegetation, geographic, and socioeconomic factors. So 3 to 4 years post-restoration, not much change happening in the lower frequencies. But it's a whole different story when you look at the higher frequencies. Between 9 to 24,000 hertz, which are dominated by bats, several species of bats, and several species of high-frequency insects. And again, please look at the yellows and the blues, where you see over time, the yellows and the blues, the restored and the unrestored, aren't that different from each other, but the unrestored tend to have higher activity, which is why our models showed that restoration sites were in fact negatively associated with this acoustic activity. So when you combine the results, the sort of big takeaway is that you will have some losers and some winners when you do certain kinds of restoration. And what are the implications of this? How do we take this and help people who are actually doing the work on the ground? One of the biggest sort of messages I had for people working on this was that restoration will have varied impacts on biodiversity, and we need to define our objectives quite clearly. You can't, I think most of the time restoration is spoken of as a win-win-win for carbon, biodiversity, and people, and that's not always the case. And we can be okay with that, but let's just define that from the beginning, what our goals are. And so now, I'm going to extract you from this beautiful dry forest and take you outside to trees outside forests in South Asia. This is some work that I'm doing for my postdoc, where we're studying several different traditional trees outside forest systems or practices. And you can see that you can have low to high density planting, everything from live fences to silvipastures, agroforests, and then just large-scale plantations. And what we wanted to know is that how do these trees outside forests affect people's human well-being? And when I say human well-being, we're talking about multi-dimensional well-being, not just economic or material, which is largely what people tend to focus on. So we scanned a few frameworks, co-authors and I, and we came up with this multi-dimensional framework to understand it. And what we did is a systematic literature review. We scanned thousands of articles from several databases, dwindled it down to 325 articles. And what we found is that overall, we found that trees outside forests, whether they're these systems or practices, have a positive effect on people's well-being. What you've got in this figure is number of publications on the x-axis, and on the y-axis, you've got the different categories of well-being that I showed you and their subcategories. The greens show that there's a positive effect. The blues are neutral, as in it was just something that people said, yeah, that happens. Grays are mixed outcomes, and then reds are that they had a negative effect. So overall, there was a positive effect, but when we looked at the literature more closely, we questioned the temporality of these. So for example, in one of the papers, there's the Billion Trees program in Pakistan, and people got jobs to plant trees. But then these are temporary jobs, and they'll be gone if once the program is over. So there were a few more examples like that I won't go into right now, but it's interesting, and we need to question the temporality of these effects. And I also want to take a second to show you the negative outcomes, really, that we found only in these sort of subcategories where people felt that certain kinds of projects, and when we dug deeper, they were mainly afforestation, reforestation, large-scale programs led by the government. We found that people felt like their sense of social equality, equity in a community was affected negatively, or their ability to have a political voice in the group was affected negatively. So these are things that we also need to keep in mind. But I also, just to leave you with something very interesting, we found in terms of the characteristics of these systems. This is a lot, I know, but just look at the second line, which is the tree and forest home gardens. It's fascinating how these private lands, and specifically smallholder farms or houses, have so much such high species richness. And all of this exists on people's private land, and we're often looking at sort of communal lands for this diversity, but there's a lot in people's backyards. If you look at the second line, you see that almost 25% of the publications had a list of over 50 species. That's pretty fascinating. In contrast to efforts, TOF efforts, tree southwest forest efforts like afforestation and reforestation, where 75% of the data is less than 10 species that are being planted. And I can't show you everything that we've done and got in review right now, but basically afforestation and reforestation was mainly happening on people's communal lands. So we're kind of reducing the richness in these places. And to sum up, the two main takeaways for us was that some systems are more susceptible to negative outcomes, like I showed you. And the second one was there's some cool diversity in people's backyards and farms, and we're not thinking about that. And one of the implications moving forward is that, people focus on collecting seeds for restoration, propagation material from forests. And what if we're losing out on a large part of genetic and taxonomic diversity in people's sort of backyards and private lands? And with that, thank you so much for being a great audience. This was work that was possible due to so many people and several funders. So thank you so much.
Thank you, Pooja. I see a few questions in the front.
Thank you. Thank you for your enthusiasm. You can feel that you love this topic. So, when you're driving and from the policy perspective, thinking about interventions that benefit that biodiversity, and of course, an intervention can be thinking about restoration, but the findings that you point out are very important when we're thinking about how to prioritize this intervention. So the question is, and I don't know if it was part of your research, but at least if you have some hypothesis about it, why is it that those interventions didn't have a positive effect on biodiversity from the acoustic intervention that you did? Is it like the tree species that were used? Was it the arrangement? I mean, what type of things do we still need to be thinking about so that we can have positive impacts on biodiversity through restoration interventions? Thank you.
Thanks a lot. We had such little time that I couldn't explain. That species grows so aggressively that it sort of covers the forest floor completely, and it doesn't allow other shrubs to grow. It also reduces tree regeneration. In some cases, not all. There is different evidence from different places. And so I think what was happening, and I saw these sites only 3, and I followed them. So starting at year 3 post restoration efforts, what I think is happening is that it was kind of, when you removed that lantana, there was not much left. And I think that's affecting certain insects, because those were probably important habitats for these maybe ground insects. But again, you need to follow those sites over time as these places regenerate. And I think that we might see something different at different time steps in the future.
So we don't have time for more questions. We have just enough time for our last 2 speakers. So I'm going to ask Brendan Fisher. I lost track. Oh, there you are. Brendan Fisher is from the University of Vermont, and he's one of the two speakers here who is not an elite career person for those keeping track.
Thanks, Forrest. Appreciate it. I'm feeling my age. So while the slides are coming up, I will tell you that the title of this talk that says, "Does forest health mean human health?" Is, for those of you who are keen observers of the program, that's not the title in the program, because I couldn't answer the question that I gave in the title in the program. And just to let you know, I can't answer this question either. So if anybody has a good title for what I'm about to talk about, I'm all ears at the end of the talk. And it's coming up. Yeah. Okay, so I'm from Vermont. That's what the area where I live looks like. And next, I get. Okay, so I couldn't answer that question. Does forest health mean human health? But what I am going to talk about is a project we've been working on for a long time on human health and forest condition. And we used a big data approach. And we brought together this database. It took us 5 years to build, but each of these little dots here is a community. Inside that community, we have households. We can look inside the households and know data about the wealth of the household, the plumbing, the materials the household's made out of, where they get their water source, gender, all the children in the household, their ages, etc. We've combined that with ecological data, so lots of data on precipitation and temperature and deforestation. We've also been able to model the impact of having cattle in the watershed, human density in the watershed, forest in the watershed, and how that affects water flows. And then we have health data, so the biometric data actually inside the household measuring stunting, so height for age of children, wasting, weight for age of children, anemia, parasitemia, mortality, fevers, diarrheal disease, etc. And we brought all this stuff together, and in the end, our data set was about 800,000 children under the age of 5 across 49 countries. We brought together about 20 data sets and tons of variables to help build our models. I've used this joke before, but a few years ago I did look back at the grant we wrote to bring this project together, and we told them that we would have this database built in 6 months. And it took 5 years, and it's still not perfect. But what we did was we brought all these people into this room. We had doctors, MDs, people who ran philanthropist charities. We had hydrologists, ecologists, geologists, economists, and marine biologists, anthropologists, and a bunch of other gists in the room to try to ask these questions of how forests affect these human health outcomes that we could measure. So the first one, I'm just going to go through a series of results that we got. I'm happy to talk after the talk about the methods, etc. But dietary diversity, a really important indicator of micronutrient intake for children, and also a fairly decent indicator for food security for a household. A whole bunch of causal pathways or mechanisms we can think. So for each of these questions, we thought through these mechanistic processes of how forests might affect dietary diversity. So some directly through forest food, maybe pollinators, NTFPs to produce cash, so then you could buy more food in the market, etc. Mother's time, closer forests, reduction of time to collect firewood and forest foods, etc. And we modeled these on our whole different suite, a bunch of modeling techniques. And I'm just going to talk about 2 here. This one, matching 16. So we used a matching process, a quasi-experimental approach. 16 represents the number of countries we did this for. These are all sub-Saharan African countries. And we have an increase of about 17% increase in dietary diversity for children in households in these countries compared to households that don't have forest. We define forest as 30% of forest cover in a 5K buffer of the community or of the household. So households that don't have forest at that extent in their community. The top 2, one is all data, that's 27 countries, so it spreads into Asia and Southeast Asia, and the SSA is the Sub-Saharan Africa. These were modeled using a partial identification, which is a really simple impact estimate, and it strips away a whole bunch of assumptions about the structure of the data, and it gives you huge bounds, but we didn't care about the bounds, we cared about the lower bounds, and this work suggests that you just get this huge bump in dietary diversity when you have forest near your household. That is not earth-shattering. Tons and tons of case studies across the world have shown us that, but this is just a modeling approach to show that big data over, I forget how many households, 40,000 households also show this indication. Diarrheal disease, the number 2 leading cause of death of children in the world under the age 5, was our next question. And this, we used a mixed effects logic model to try to understand how forest cover in the watershed above where the household is, thank you, affects diarrheal disease. And so these are normalized coefficients, so we compare them across each other. And down in the bottom, we see that the impact of having forest cover in your watershed is about the same as having a wealthier household, a more educated household. It's more than having indoor plumbing. So again, forest moderating the effect of disease in the water for surface water extraction of water for children. Similar approach. We just finished this work looking at malaria prevalence. A similar modeling approach. 12,000 children, 6 countries in sub-Saharan Africa. Obviously, so again, these are the partial impacts, all normalized so we can compare against them. But you can see rural residents, you're more likely to contract malaria if you live rurally and experience deforestation. And then the deforestation signal, huge bounds on it, but a real impact as deforestation goes up, incidence of malaria goes up. This is like wave of the hand, magic hat, pull the rabbit out, because this isn't about forest cover. We actually looked at the governance regime here. This is about protected areas. So a lot of these protected areas have forest in them, but I wanted to show this result as well. This was for about 60,000 households. We used matching approaches and Bayesian hierarchical models across 34 countries, about 600 protected areas in the world. And this is for stunting, so the child's height for its age. And near multi-use, tourism-happy protected areas, we see a huge impact on a huge increase in, this is an improvement, a huge decrease in stunting in those households that are near those type of protected areas. We can scroll all the way down to a really strict PA, and what we see there is there's not a huge cost. There's variance there, so there are case studies where having a strict protected area will have negative health impacts for you, but on average, there's not a huge cost to the household health across these 600 protected areas. So, that was a lot, but the subtext here is reduced diarrheal disease, increased dietary diversity, reduced stunting, reduced anemia. So in the dietary diversity work, we also looked at anemia, looked at vitamin A, vitamin C, and iron-rich foods, and reduced malaria incidence. But it's not for everyone. So there is a distribution result here that the diarrheal disease forests are only really helping in the rural areas. Dietary diversity, most significantly for the poorest households that are utilizing their time to go out and collect these forest foods. Reduced stunting for the poorest and with forest access. Reduced anemia is most significantly for the most educated households. So households that know how to get vitamin A, C, iron, etc., and utilize their scarce resources to improve health. And then reduce malaria, only for the poorest households. We look at bed net use too in another project, but also only in the range of certain ecological vectors. So the dominant vector species certainly behave differently, and so when we put them in the model, we see that these impacts only really happen. Forests don't reduce malaria in places where the dominant vector disease loves to feed on cattle. So we don't see that. So kind of as a check for our models. I want to say 2 more things, and I think I have 1 minute. This was work mainly driven by amazing set of postdocs, Renaiva Rasalafasan, Alicia Ellis, Diego Herrera, another colleague, Robin Naidu, and Tefesa Stefanos. They've done all the work. They're amazing. And the last thing I'll say is last year, or this year actually, the International Union for Forest Research Organizations put out this report all about international forest governance. Ida here was an author on one of the chapters, and you can download it. I can put this slide back up in a second, but I want to get to this slide. This is a figure from this report. There's a lot going on, but this was all about how the discourse, how we talk about forest and international governance across the globe over the last 65 years. And there's lots of different themes coming, but the big theme is climate change. All forest in these international discourses being discussed in relation to climate change. And the authors of this chapter suggest that there's carbonization and climatization of forest discourses such that it's becoming in this hegemonic meta discourse. And we heard from the plenary today, which was that way, about the other global change or land use change. So other values do seem to be getting lost in this meta discourse. And with this work, we just want to say that human health from forest is another discourse that we kind of need to elevate. And an investment in forest is an investment in human health in many cases. Thanks.
I think in the interest of time, we can have questions. You can find Brendan right after the talk. We have 15 minutes left. I want to make sure we have time for our last presenter, who's Fatima Ali. Fatima is a PhD student in Bonn University.
Thank you. It was quite challenging, the last presentation, but it's good. I'm gonna take you for very small scale data, very imprecise, which is maybe. So I'm Fatima Ali. I'm a Sudanese, and today I'm gonna present you about participatory future scenario for Okalmo Forest. And how to say next? So first of all, Okalmo Forest is a gum arabic forest, and gum arabic is a natural or semi-natural forests that provide essential ecosystem services to the people in Sudan, but also around the world. And if you wonder, gum arabic, or I would prefer Sudanese gum, is a non-timber forest product that is used as a stabilizer and binding agent in medicine, food, and non-food industry. So if you drink soda or take a medicine, or even wear a makeup, definitely use a gum arabic without you know. So gum arabic is like a precious hidden product from the dry forest. So these services, as we know, are under threat of over-exploitation, and perception of forest use for the community may exposure to various drivers of change. Moreover, as we focus on the future scenario of forest, the conflict may arise between the community who live near to the forest and far away from the forest. So our research question is, how do forest-dependent community envision the Okalmo forest use in 2050? So this is how it looks like the gum arabic. A gum arabic is produced after you make a wound in the tree. This is how it's look, and this is like the final product. So I'm gonna give a lot of details in my research, and it's not like, but we combine participatory data and with non-participatory data in order to have a transdisciplinary evaluation study. So here you can see Okalmo forest is allocated to Sudan in Sinai state near to the Blue Nile. And if you see from recent Sentinel image in this month, the forest is located in agricultural landscape. And we chose to focus in two villages. One we call it as a distant village, and one as a closest village, in order to compare if the distance could affect the people's perception regarding the forest use. So, but before we envision the future, we go back. We draw our model in the African wisdom, Sankova, which is this bird looking back to collecting the golden age. So we let the community draw the previous forest use history since 1942 until the 2022 in the time of the study area. And so, because we combine the community narrative with remote sensing analysis, I did here segmentation for Landsat with the 30-meter resolution. And the forest usually, if you was wonder, the forest managed by the government, they divided to different blocks in order to produce different services. And usually the government, when they find like the tree that not efficient to produce gum arabic, they just give it to the community to do agroforestry system and do restoration, which is called tongia, and it is invented by British colonizer. So the community said, like in their narrative, in the 80s the forest was really good, and they used it mainly for gum arabic and mechanized trade fit, which is a tongia practice. And we see here, just focus on the green, this color, give me motivation. So focus only in the dense creek over here. So and yellow is the farm area. In 90s, the community describes this as a period of the beginning of forest deterioration. And we see here in our analysis, the sparse tree to bare land cover was higher than the dense tree cover. In 2000, in the 90s also the forest started, the government to allow charcoal production. So in 2000, the forest was used to produce different conflicting services, I prefer to say. A part of it was gum arabic, a part of it agroforestry, a part of it for charcoal, and of course grazing, because the nomadic population at that time, they started to settle. So we see here like the light gray is like a sparse tree to bare land, is very dominant. In 2008, after a lobby by gum producer with to the governor of the United States, he started close the forest and prohibited any activities. So we see here in 2009, we didn't find a nice picture for Landsat in 2008. So, but here in 2009, we can see that the forest started to recover comparing to 2001, but the high recover is very obvious in 2014. But the funny fact, this picture in 2023, which is after around 5 months of the war in Sudan, the forest become like almost closed. So now, there is ongoing war now in Sudan, and I'm not promoting war, but the forest become higher. This also concerns the question. So in order to see like the forest area is around 70,000 hectares, and we can see here like how much the forest cover going up and down, based with the community narrative in selected year. So we draw two scenarios, which is very simple with the community. One, we call it as undesirable scenario. The undesirable scenario, the forest without protection and with the same economic condition, but the people, as we did this study before the time of war. And the desirable scenario is with the forest with the guard, but the government willing to achieve development. So maybe the government will change. So we draw the same scenario for the two villages in order to draw our comparison. So what is our end desire? So the community draw each 5 years, but we're gonna here present only in 2050. Our undesirable future, we have the motto, the Sudanese proverb, if your father's house is destroyed, take something out of it. So is the forest without government, without protection, everyone eager to take something out of it, charcoal or whatever. So focus in the middle column, the shared vision for the local people. They said, as we see, the people have the farm around the forest. They said, of course, we're going to have a low productivity because the forest will going to vanish, and drought and desertification will happen. But the closed village also imagines that the wildlife will go to escape, increase undesirable tree, invasive species, sickness for human and animal due to the sandstorm. And sandstorm, believe me, sandstorm is a big deal in dry arid zone. So the people really appreciate the regulating and provisioning and cultural service of the forest. And as I said, the village will gonna disappear and on migration. The distant village, they said, no, the forest will gonna be converted as a farmland with a conflict. This is like a continuous scenario in Sudan. There is a fight, there is a conflict everywhere. So, and they reduce livestock because they're gonna have less pasture area. So, for the desirable future, we have our motto, the Sudanese proverb: may goodness abound for all, and may life progress well and straightforward. Homemade. He's a Sudanese. So, and the shared vision, they said the forest will be in excellent condition, but this is if they have economic stabilities. What they mean by achieving economics, they said development of hospital, road, beautiful schools, factories, productive farming. This is like the basic needs. So you can imagine how they live now in the time of the study area, and you can add extra how they gonna live, how they living now inside the war. So the closed village, they said So, but this was interesting. The closed village envisions that they're going to use the forest, even in 2050 with a good economic achievement, they're going to use the forest for different services, for the same they do in 2022, for fruit, grazing, cosmetic firewood. And they said we're going to have less problem with the gum tender. As a village, we're going to have electricity because at that time they don't have it. But the distant village, because they have electricity and water, they didn't think about that. But they said forest we're gonna support diverse range of wildlife, and maybe we're gonna use the forest for recreation rather than timber. So even in the same two communities, they have different vision. So to conclude this, historically, the forest never turned into a desert, and it has a deterioration. We can say, based on FAO definitions, there is a deterioration, there is a degradation, but there is no deforestation. But maybe you can critique like, you use only low resolution data. Oh, yeah. So, but we use the only resolution data because this is the only data I have. And this is aligned also with the community narrative. They said, as long as there is a protection of forest, the forest will never be vanished. And the second thing that there is evidence impact of the government's decision on forest recovery. Because when the forest governor make a decision to close the forest and prohibit different activities, the forest recovers. So there is a clear evidence. But there is also uncertainties like war. And war is something as a possible scenario in Sudan. But when I was drawing the future scenario with the community, they was feel uncomfortable. They said, you want to make us a problem to speak about the political and the government. No. And this is very important for us as a researcher to think about the pedagogy of oppressed. Participatory scenario, participatory research is really good. But when you do with the marginalized, oppressed people, we need to be careful and to address this limitation. Or maybe you need to take more time. And the community envisions a simple pathway system. If we have alternative, we're gonna leave the forest. If we don't have alternative, we're gonna convert it to, we're gonna use it for timber, for firewood, or for charcoal. This is like the simple scenario because they appreciate the regulating services, but they don't have option. So in order to understand also the full community narrative, we need to consider all Y, all W. Like always, the community eager to tell you a lot of story about what they are doing, what's happening, but what alone is not enough. We need to know how, when, where, and by whom. This is really important. Then I can say also participatory. I cannot say like remote sensing data is really nice, non-participatory is not good. No, both of them are important. For example, the community tell me about the wildlife, which is I cannot trace it through remote sensing data. Remote sensing data allow me to count the forest cover in hectare, which is I cannot have it with the community. So both of them are complementary to each other. And I would like to say thank you, and I would like to conclude that since the 70s, we destroy and remove our natural habitat to produce a natural product that is exported for the raw material. We don't get benefit of it. We just export it as a raw material for developed country, developed country. So we are losing our natural habitat for nothing. Thank you.
So we do have time for maybe one or maybe even two questions. So we have about 4 minutes left. And before I call for questions, I just wanted to add a plug that I didn't get to include my paper in this session, which is also about very related topics. And it's in a session in the afternoon that I don't remember the title of, but it's in the Mixteca room. So.
Question, please. Yes.
Thanks, Fatima, for your nice presentation. I'm happy that you are laughing even if there's war in your country. That's quite inspiring. My question is on your visions. Were these gender-based, or did you just work with an heterogeneous group and just get mixed results from it?
Okay, good question. So for the two village, I tried to do the scenario for women alone and for men alone. But the problem was for the distant village, the women, they didn't use the forest. They used close forest near to them. So it was really difficult to them to envision the forest far away from them. But I let them to do the envision of future scenario for the forest near to them. But it was really difficult to include it here. So I need to say like I only include the main vision. in the future scenario. But I have the woman vision, which was sometimes a little bit different from me. Yeah. Yeah, please.
Hi, thanks for a great presentation. I wanted some more clarification on the nature of the forest that has changed. So you mentioned that gum arabica is the major product, and the governor intervened and sort of banned a whole bunch of other activities, presumably, as you said, under the pressure of the gum producers in order to restore the forest. But what it means is restore a gum arabica forest. So my question is, would you say that over time the forest has become more homogeneous and only producing gum arabica and other species are gone? Is it like more like a plantation now, or what's the compositional change in the forest?
Okay. I don't have the data here for the compositional change, but so the gum arabic trees, which is two species, Bechelia senegal and two species, are multi-purpose trees. So the community, the same tree that produce gum arabic, the community use it as a cosmetic firewood, which is a cosmetic used by women, and also can use it as a firewood, and it is also useful for timber and charcoal. So the same tree can produce different services, which is so the community, local community, interested to have the tree to use it as a charcoal or timber rather than gum, because usually the gum production is gum through the tender. So the government opens the tender and you come apply. So if you don't have enough money, you cannot have, but you're gonna work as a labor. So we have the forest in the past, like when they said in the narrative in 1942, the forest was diverse wildlife with the many species. There was tree producing gum, but through the selective management of the government, the two species that producing the gum become dominant, like 80% maybe we can say. But there is other tree that is useful for grazing. So it is it is semi-natural forest, we can say. Did I answer your question?
Yeah. So you're saying that it's not necessarily a species change so much as a use change.
Yeah,
multiple use, it has become a single use forest where the government is extracting the surplus, by auctioning gum harvesting rights.
Yeah. So to emphasize, so the same tree produce different services. And the people use the forest in different seasons. Like in winter season, they produce the gum. In rain season, the pastoralists go, and in dry season, they use it for different things. So there's also different season, and this shows the dynamic, which is really difficult to monitor with remote sensing. And so the same tree produce different things, and I describe it as my research as a conflict. The government describe it as a forest infringement, but for me, I see like the community have interest in forest in different perspective, as the government have a different perspective because they want to export it. Yeah. Thank you.